My name is Nathan Van Katwyk. My teammates were Braden Pape and Collin Boren, and we have made a model house with a temperature control.
Here is our setup. We wanted to resemble a house as much as possible. We bought one of the painting kits that you can buy from your local craft store, which is made out of wood, to represent the siding and the wood that is found in the internal framework of your house. We also embedded it into this styrofoam base to act as kind of the foundational layer to keep it secure and also to act as insulation. We put plastic in the windows to act as a barrier for heat inside the house, and then also internally we sprayed foam insulation, and this kind of acts as the insulation that is found inside your house. Now our hardware is everything is run by this Raspberry Pi. It receives the temperature readings, it runs the PID control loop, and then it spits out the output for this TCLab to produce. This TCLab will heat up the house, and to facilitate some airflow, or a little bit better airflow, we included this little fan, and all its sole purpose is to circulate the air. The temperature readings are read in every second from this DHT11 temperature and humidity sensor. This temperature and humidity sensor is accurate to about the degree, and it receives and sends information about once a second for the Raspberry Pi to then process.
This is the Node-RED dashboard that we built to be able to monitor the heater and the house temperature as it is running. Up in the upper left-hand corner, you can see that this is the house temperature. That's the temperature reading that the DHT sensor is sending to the Raspberry Pi. You can also see the desired temperature or the set point that we wish to specify. You can change that by decreasing or increasing with these arrows here. The house humidity as well as heater temperature and heater output are also shown to show the progress. You can turn off the auto control or the PID loop by this switch here. If you turn that off, you will see that the heater output will go down to 0 because the heater will then turn off, and you can turn it back on to be able to start the PID loop up as well. We can also increase the set point, and we will be able to see that increase in the graph here. This graph is the house temperature, the one below it is the heater output, and this bottom one is the heater temperature. We don't want the heater temperature to go above this 90-degree Celsius range. Now all of this is run through the Node-RED flow. Now everything on that dashboard is updated every second. Each of these nodes will fetch a file that has the value that is then output by those gauges and displays. The Python script also exports the graphs and exports various files in order to be displayed on this dashboard. This dashboard helps us be able to track the progress and see how efficient we are and be able to tune the parameters of the PID control loop. Here's the Python code that is running on our Raspberry Pi to run this system. We first start by reading in various values and initializing arrays. We then wrote the PID control function. We only have a PI control, and we optimized the tuning parameters manually. We ran it for multiple hours, and we found the optimal tuning parameters for our system where it is currently located. We then wrote 3 while loops, one for each scenario. 1 while the switch or the auto control is off, 2 when the switch is on and the temperature is less than the set point, and 1 when the temperature is greater than the set point. We needed that to be able to tell the code when to run the PID control loop for the output or when to set the output to 0. We then have a few error checkings, and we append our data points to our arrays, as well as export some files to be displayed on the Node-RED dashboard, and then we export and make our plots that you see on that dashboard. We pause for a second, and then we recheck the switch and we run again.